Hi, my name is AnaMaria and I'm going to present my project about development of an ozone generator. We have used it for sterilization of some common stuff and the results are amazing. How do we get ozone? In the nature, the sun is constantly splitting oxygen molecules into single atoms due to the intensive UV radiation. Those atoms are then combined with other oxygen molecules, creating ozone. Created ozone layer has the ability to absorb the UV radiation from the sun, or more specific, the UVB radiation. A part of the natural ozone generated by the sun, ozone also can be created so-called ozone generators. There are two general technologies in usage: UV radiation and corona effect through strong ionized discharging technology. In our project, we decided to generate ozone through so-called strong ionized discharging. Practically, the ozone generator is made from three main parts: high voltage DC generator, shielded discharging chamber and small air pump. High voltage generator produces about 7,000 volts DC. In sealed discharging chamber, this current is discharged, creating small sparkles and creating ozone. Due to the higher inner pressure, ozone is leaving the chamber on the other end of it. Cockcroft-Walton generator is created by ladder network of capacitors and diodes. In the positive half cycle of the AC diode is conducting and charging the capacitors. In the negative half cycle, diodes is highly resistant and this stops capacitors discharging. At the output, after number of pairs 50 seconds with actually no output load, output voltage is equal to the input voltage multiplied by number of stages. After soldering and successfully testing on the generator, we made discharge relatively simple by using test tub. Inside of the test tube, we insert an aluminum foil used as a negative electrode, and on the outside, coil of copper wire used as a positive electron. The total cost was approximately 30 euros. We spent some 15 euros for diodes, 12 euros for capacitors, and 10 for air pump. The next step was to check capabilities of our ozone generator for sterilization. It is well known that TV remote controller is a major gem hub, so we decided to see how efficient is our ozone generator in sterilization of the controller. We took 3 swabs from the controller, the first one from non-treated controller, then treated for 30 seconds in our ozone chamber, and the last one treated in 120 seconds. The results were quite encouraging. As you can see, the first petri dish on the left is swabbed from untreated controller. It is obvious that it is quite contained with bacteria. The second one in the middle is swabbed from controller treated for 30 seconds. It can be seen that the bacteria population has been significantly decreased. And the last one on the right is swabbed from controller treated after 120 seconds, and it's obvious that it's sterile. We do expect positive results, but we were quite surprised with the speed of sterilization even with our small ozone generator. After success of our first experiment, we decided to continue research with other devices we use in our daily life. Mobile phone is definitely one of them. We took 4 swabs from my mobile phone. The first one was untreated, the second one after 30 seconds, third one after 60 seconds, and finally the fourth one after 120 seconds. The results were similar to the previous experiment. After 120 seconds of treatment in the ozone chamber, my mobile phone was completely sterile, as can be seen on the last probe. Paper money is exchanged on daily basis. Are they clean? To see what we are dealing with on cashiers every day, we made a similar experiment with paper money in appointment of 100 Macedonian dinars. Probably the dirtiest results we've ever obtained. As you can see on first probe, paper money are really full of bacteria. And again, after 120 seconds of sterilization, the money became sterile. The last experiment was water sterilization. We put some soil from my father's plant pots, which is naturally rich with different types of bacteria, fungi, and viruses. We mixed distilled water with soil, and after a few minutes we had filtered it. We made 4 swabs on no treated water. After 30, 60, and finally after 90 seconds of ozonation, it is quite obvious that the process of ozonation is even more efficient in water compared with previous experiments. Ozone is the most efficient oxidizing antimicrobial agent known so far. The main advantages of sterilization processes with ozone are: can be created from air and deplete again the oxygen, so no waste products to take care of. Can be used as a low temperature sterilization process for the equipment which is sensitive to the temperature or humidity. Even very tiny amount of ozone could be detected from its pungent smell. The main disadvantage of ozone is that it's toxic and flammable. Ozone has great sterilization potential, especially in cases where low-level temperature sterilization is needed. It has been used for many years in disinfection of drinking water. Ozone is relatively safe and its use is quite cheaper compared to other alternatives, such as formaldehyde or hydrogen peroxide. We believe that in the near future, ozone will become a viable alternative for low-temperature sterilization processes.